Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that is absolutely essential for any developer, especially if you're working in a team: Git and version control. Ever been in a situation where you made a change to your code, it broke everything, and you wished you had a time machine to go back? Well, that's exactly what version control systems are for. They're like a safety net for your code, tracking every single change you make. And when it comes to version control, Git is the undisputed king. So, what exactly is version control? Imagine you're writing a novel. You write the first chapter, save it, then you revise it. Save it as chapter 1, version 2. Then you get feedback and save another copy as chapter 1 final. No, really final this time. It gets messy, right? A version control system, or VCs, automates this entire process. It keeps a history of all changes, lets you revert to previous versions, and see who changed what and when. This is a lifesaver for solo projects, but it becomes non-negotiable when you're collaborating with others. There are different types of version control systems. The older ones were centralized, meaning there was a single server that held all the code history. Everyone would check out files from this central server, work on them, and then check them back in. This works, but it has a single point of failure. If that server goes down, nobody can collaborate or save their changes. This is where distributed version control systems, or DVCs, come in. And guess what? Git is the most popular DVCs out there. With a distributed system like Git, you don't just check out the latest version of the files. You fully mirror the entire repository, including its full history. So, every developer has a complete local copy of the project. This means you can work offline, commit your changes locally, and if the main server is down, it's not a disaster. You can still work. And once the server is back up, you can push your changes. This model is incredibly flexible and robust, which is why it's the standard for modern software development. Now, let's talk about the Big G Git. Created by Linus Torvalds, the same genius who created the Linux operating system kernel, Git was designed to be fast, efficient, and great at handling large projects. When you start with Git, you'll hear a few key terms. The first is repository or repo. For short, this is just a fancy word for your project's folder, where Git tracks all the files and their history. This history is stored in a special hidden subfolder called Git. The core workflow in Git revolves around a few key concepts. You have your working directory, which is where you actually edit your files. Then there's the staging area, which is like a draft space. Before you permanently save a set of changes, you add them to the staging area. This lets you be very specific about what changes you want to include in your next save point. Think of it as carefully selecting which items to put into a time capsule. Once you've added your changes to the staging area, you commit them. A commit is a snapshot of your staged changes at a specific point in time. Each commit has a unique ID and is accompanied by a commit message. Writing good commit messages is a skill in itself. A good message explains asterisk why asterisk you made a change, not just asterisk what asterisk you've changed. This creates a clear and understandable history of the project, which is invaluable for you and your teammates down the road. So the basic local workflow is, you modify files in your working directory. You use the git add command to move those changes to the staging area, and then use git commit to permanently store that snapshot in your repository's history. You can look at your project's history anytime using Git log. It's like having a perfect memory of your project's entire life. But the real magic of Git happens when you collaborate. This is where remote repositories come into play. A remote repository is a version of your project that is hosted on the internet or a network. Most famously on platforms like GitHub, GitLab, or These platforms are built around Git and provide a ton of extra features for collaboration, like issue tracking and code reviews. Your local repository can be linked to one or more remote repositories. When you want to share your commits with your team, you push them to the remote repository using the git push command. This uploads your committed changes. Conversely, when you want to get the latest changes that your teammates have pushed, you pull them from the remote repository using git pull. This command fetches the changes from the remote and merges them into your local working directory. This push and pull cycle is the heartbeat of collaborative coding with Git. Now, what happens if you and a teammate change the same line of code in the same file? This is called a merge conflict. Don't panic. This is a normal part of working with Git. When a merge conflict occurs, Git will pause the merge process and tell you which files have conflicts. It will then mark the conflicting sections in the file itself, showing you your version and the version from your teammate. Your job is to manually edit the file to resolve the conflict, choosing which version to keep or combining them. Once you've fixed it, you add the resolved file to the staging area and commit the merge, and you're back on track. To make collaboration even smoother and more organized, Git has a powerful feature called branching. Think of the main line of development as the main or master branch. It's the stable, official version of your project. When you want to work on a new feature or fix a bug, you don't work directly on the main branch. Instead, you create a new branch from it using Git branch and Git checkout. A branch is essentially an independent line of development. You can work on your new feature on this branch, making commits without affecting the stable main branch. Your teammates can be working on their own features in their own separate branches. This keeps the main branch clean and functional at all times. It's like having parallel universes for your code. Once your feature is complete and tested on its branch, you're ready to integrate it back into the main project. You do this by merging your feature branch into the main branch. You switch back to the main branch and use the git merge command specifying the name of your feature branch. Git will then take all the commits from your branch and apply them to the main branch, combining the histories after the merge. The main branch now contains your new feature. You can then delete the feature branch to keep your repository tidy. This branching and merging workflow is the cornerstone of modern collaborative development. It allows teams to work on multiple things at once in an organized, parallel fashion without stepping on each other's toes. A common practice is to use pull requests or merge requests on platforms like GitHub. Instead of directly merging your branch, you open a pull request. This is a formal request to merge your code, which allows your teammates to review your changes, leave comments, and suggest improvements before it gets integrated into the main branch. This code review process is crucial for maintaining code quality and catching bugs early. So let's quickly recap the collaborative workflow. First, you pull the latest changes from the remote main branch to make sure your local copy is up to date. Then, you create a new branch for your task. Let's call it New Feature. You work on this branch, making commits as you go. Once your feature is done, you push your branch to the remote repository. Then, on a platform like GitHub, you open a pull request to merge your new feature branch into the main branch. Your team reviews the code, and once it's approved, the pull request is merged. Your new feature is now part of the main project. Finally, you can pull the updated main branch back to your local machine and delete your now merged feature branch. Getting comfortable with Git takes practice, but it's one of the most valuable skills you can learn as a developer. It's the foundation of how modern software is built. It empowers teams to work together efficiently, maintains a complete history of the project, and gives you the confidence to experiment without fear of breaking things permanently. So, my advice is to start using it now, even for your personal projects. Initialize a Git repository, make some commits, create a branch, and merge it. The more you use it, the more natural it will become. There are many great graphical user interface tools for Git, like SourceTree, GitKroken, or the one built into VS Code, which can make it easier to visualize what's happening. But I highly recommend learning the command line interface first. It gives you a much deeper understanding of how Git actually works under the hood. That's a wrap on our introduction to Git and version control for collaborative coding. I know it's a lot to take in, but trust me, mastering this will change the way you code forever. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe for more content that will help you level up your developer skills. Drop any questions you have in the comments below, and I'll do my best to answer them. Thanks for watching, and happy coding!